Hi everyone, my name is Shimmila Bhowmick. I am a PhD student at Indian Institute of Technology, Guwahati, India. So what am I going to present today is a small part of my PhD research in the area of gesture-based object selection techniques in VR. So on behalf of my co-authors, Nilotpal, Biswas, PRATUL, KALITA, and Keyur, Sorathia, I will be presenting our work, which is titled, Wow, I Have Tiny Hands, Design and Evaluation of Adaptive Virtual Hands for Small Object Selection within Arm's Length in Dense Virtual Environments. So virtual reality is a simulated 3D environment that makes use of computer modeling and enables a person to interact in a three-dimensional environment as if it's almost real. VR has been used in multiple and wide variety of applications in the context of virtual prototyping, industrial training, architectural walkthroughs, and in the context of scientific and molecular data visualization. VR enables scientists to visualize and understand the dynamic arrangement of molecules to analyze relationships with each other, and also it helps them to make accurate and efficient decisions. In this context, object selection is of utmost importance. Selection is actually a process of indicating a target object for subsequent action. It precedes object manipulation, locomotion task. Hence, object selection is a fundamental and a primary task for most common user interactions in a virtual environment. Considering all of these use case scenarios like scientific molecular visualization and data visualization, the objects could be very small, the size of a nail, and could be positioned at varying distances from the user, and could be arranged in a dense virtual structure, thereby increasing the challenges of object selection in VR. So in this context, we designed the tiny hands technique. So the principal idea of the tiny hands technique is to be able to scale down the size of the dominant virtual hand to facilitate small object selection in dense environment. The user performs the vertical downward movement to scale down the size of the virtual hand, and now the tiny hands is able to efficiently select the small target. The tiny hands technique is also able to easily navigate in a dense virtual environment, thereby facilitating and helping the selection process of a small target in a dense virtual environment. The user then performs the vertical upward movement using the non-dominant hand, and the virtual tiny hand is again back to its actual size. So in order to investigate the effectiveness and efficiency of the tiny hands technique, we performed an evaluation of tiny hands. The objective was to investigate the efficiency and effectiveness of tiny hand selection method in a dense virtual environment where the targets are kept within hand's reach. So we compared tiny hands technique with raycasting techniques and the Oculus pinch to select technique. So overall, our results indicate the tiny hands technique was significantly faster in terms of task completion time as compared to other techniques. Tiny hands technique also performed 0 errors. In terms of ease of use, ease of learning, and naturalness, tiny hands was significantly easier to use. It was the most natural, and it was also easy to learn. Participants also preferred the tiny hands technique as compared to other techniques. So in conclusion, I would like to say that tiny hands technique provides a natural and intuitive way of interacting with small objects in a dense virtual environment. It also offers a promising solution to the problems of selecting small objects in a dense virtual environment. So as future work, we want to investigate tiny hands in a real application context, example, insulin molecular model or a human anatomy model. And also we want to investigate bimanual interaction of tiny hands for distant target selection of small targets in dense virtual environments. So yeah, this wraps up my presentation. I encourage you to read our work. So thank you.